So earlier in the chapter, we talked about piecewise functions and evaluating piecewise functions. Now let's talk about sketching their graph. As you may recall, a piecewise function is a function that is defined by multiple equations over an explicitly stated domain. Its graph is the collection of all ordered pairs that are solutions to the equation. Example, sketch a graph of the piecewise function. Here we have the piecewise function f of x, and notice that there are two pieces to this piecewise function. The first piece says y is equal to negative 1/2 x minus 6 for x values that are less than or equal to 4, and y is equal to x plus 5 for x values that are greater than 4. Again, make note that these quantities that are to the right of each piece are the specified domain. Those are the values of x that they are talking about. In my opinion, the easiest way to sketch these piecewise functions is to begin by graphing each function on the same coordinate plane. Graph each piece of the piecewise function on the same coordinate plane. So let's talk about the first one. Y equals negative 1/2 x minus 6. Well, you guys all know that this is a linear function. It has a y-intercept of negative 6 and a slope of negative 1/2. So we could plot that y-intercept. Our slope is going to be down 1 to the right 2. And we can then connect the dots, giving us our line. Y equals negative 1/2 x minus 6. All right, the second piece of our piecewise function, y equals x plus 5. Well, again, we have another linear function. The y-intercept of this linear function is positive 5, and the slope of this line is going to be 1. All right, there we have our second line. All right, so now we have both of our lines plotted on the same coordinate plane. And hopefully, as you should with all of your math, be doing this in pencil because we're going to have to do some erasing. Okay, once we have both of our curves or all of our curves plotted on the same coordinate plane, we then erase the unnecessary portions of each graph so that they correspond with the specified domain. Okay, notice that for this first piece, this was our blue line, negative 1/2 x minus 6. We are only talking about x values that are less than or equal to 4. So here is x equals 4. That means everything to the right of that on that blue line, okay, is negative 1/2 x minus 6. Everything to the right of that we can erase. Similarly, for our second piece, y equals x plus 5, that only corresponds to x values that are greater than 4. That means that we can take everything that is to the left of 4 on the red line and erase it. Now, one thing that will also help you is to plug in the endpoints of the specified domain. Right? This is going to help us in plotting another point. And you will have to determine whether or not that endpoint is going to be an open circle or a closed circle. Closed circles represent included endpoints, and open circles represent points that are not included. So notice, if we plug in 4 into the first piece of this piecewise function, I get negative 1/2 times 4. That's negative 2 minus 6 gives me negative 8. So I should have the point 4, negative 8 on my graph. All right, notice here's x equals 4. Here is negative 8. I'm going to put a filled in circle because that point is included, right? We want less than or equal to 4 in this case. So I'm going to fill in that circle right there at 4, negative 8. And I'm going to erase everything that is to the right of that point. Similarly, I also want to plug in the endpoint of my second piece. All right, so I'm going to, again, plug in 4. Okay, I know that sounds a little counterintuitive because we know x can't equal 4, but we can get infinitely close to 4, and plugging in 4 is going to be the easiest way to figure that value out. Except when we graph it, we're just going to use an open circle. So if I plug in 4 into the second piece, that gives me 4 plus 5 is 9. 4, comma, 9 is going to be the ordered pair. Here I have x equals 4, y equals 9. Now again, because this endpoint is not included, instead of doing a filled in circle, I am going to do an open circle here. And then I'm going to erase everything to the left of that open circle. Okay, because I only want to include x values that are greater than 4. All right, following those steps should leave us with a graph that looks just like this. Again, notice that I have the closed endpoint at 4, -8, and I have the open endpoint at 4, 9. Let's try one more here. Sketch a graph of the piecewise function. Notice that this piecewise function actually has 3 pieces to it. Again, begin by graphing each function, each piece of the piecewise function on the same coordinate plane. All right, let's look at our first piece, y equals x. Well, you guys all know that this is an equation of a line, has a y-intercept of 0 and a slope of 1. Plot my y-intercept, know that my slope is 1, draw in the appropriate line. Let's look at the second piece of the piecewise function. Now, this one's a little bit interesting. This is telling me that when x is equal to 2, I get out 3. And because this only includes one x value, this is actually going to be a singular point. When I plug in 2 for x, y is equal to 3. That means I have the ordered pair 2, 3 as a solution point on my graph. 2, 3. And the third piece of our piecewise function, we have -1/2 x plus 5 is greater than 2. Well, we know, again, I have another linear function. The y-intercept is +5, and the slope is -1/2. So here I have my y-intercept right up here at the top, and my graph is going to go down 1 over 2 units. Okay, now that I have plotted each piece on the same coordinate plane, we want to erase the unnecessary portions of each graph so that they correspond with the specified domain. Okay, again, we want to make note of open or closed endpoints. Closed circles represent included endpoints, and open circles represent points that are not included. Okay, so let's look at this first piece. Again, plug in the endpoint. When I plug in 2 for x, I get out 2. That gives me the ordered pair 2, 2. But because there is no equal component here, I'm going to put an open circle at 2, 2. 2, 2, open circle. After I do that, I can erase the portion of the blue line that is to the right of that open circle. Erase that entire portion that is to the right of that open circle because I only want x values that are less than 2. Well, with our middle piece, 2, 3, I don't really have to erase anything. That's still just going to be this singular point. For the next piece of my piecewise function, again, let's plug in 2 to get where the endpoint is going to be located. So if I plug in 2, -1/2 times 2 is -1, plus 5 is going to give me 4. I should have the ordered pair 2, 4. Now, again, I'm going to use an open circle here at 2, 4. The reason I'm using an open circle is because there is no equal component of this inequality. It's just greater than 2. So once I draw in that open circle at 2, I'm going to erase the portion of the graph that goes to the left of that open circle because I only want to include x values that are greater than 2. Doing so will give us a graph, a final answer that looks like this. There you have it, graphing piecewise functions.